All right, more fun with the power rule and U substitution. It may seem like I'm beating this to death, but the power rule is by far the most common type of integral you'll see. It works for polynomials. A lot of times when you see stuff that you don't think is the power rule, it's going to be the power rule. So like if you had sine squared 5x or something, well guess what? That's a sine 5x that's squared. So you might want to use the power rule on that, assuming your du matched and everything. But the point is that the power rule is super common, either through really blatant polynomial type stuff, or parentheses, or with other functions being squared and cubed. So let's take a look. All right, so here's one that's more in line with what we've done in the previous videos as examples. So the step number one is always going to be to identify your u and see if your du matches, right? So we got to write down u. So since we're doing integrals with the power rule, our u is going to be whatever's got the exponent on it. So looks like this whole thing right here is going to be our u. So our u equals 3x squared plus 1, which means our du, just the derivative of that, would be 6x and a dx. All right, so the question is, do we have this? Oh look, yes we do. So it looks like we have exactly the du we wanted. That was nice of me to cook up a problem that was already perfect. So that means we can just integrate it. Now, the way I would do it is I would just immediately jump to the answer. I would say, oh, so that means I just increase the exponent by 1. And divide by the new exponent, add a c to it, and bam, we're done. But of course, if you haven't watched the video right before this, the second one in this chapter, definitely watch that now because your teacher probably wants you to do it a little bit more of a mathy way. So I'll do that. For the mathy way, we're going to now say, you know what? We should really rewrite the original problem in terms of u. So that the original problem was u cubed, and then all that stuff, that 6x dx, was just our du. So then they would integrate it and get u to the fourth over 4, so just basically treat it as a variable to the third power. And at this point, they would substitute back in for u, because remember that u equals 3x squared plus 1, so that means we can stick that back in. And you can see all they did was just add this extra sort of step in the middle of it, but there you go. That's what your teacher will probably make you do. All right, so order doesn't matter. That means that again, we got a power rule situation. This 4x cubed doesn't quite look as important as this parenthesis to the cube power. And once you've done a lot of these, you'll start getting really good at spotting that. But, dollars to donuts, this is probably my u. So I'm just going to take a guess that my u is x to the fourth plus 1. Now, of course, once you're experienced with these, you wouldn't even write this down before you'd figure out. You would sort of do a hypothetical experiment in your head and say, well, gee, if I make x to the fourth plus 1 my u, what would my du have to be? And you'd be like, oh, the derivative of that is 4x cubed. And you say, oh, look at that, there's a 4x cubed. Awesome, so it's going to work out. Now I just need to do the busy work. So then I need to show my work. I'll write down u equals x to the fourth plus 1. And then that means my du would just be the derivative of x to the fourth plus 1, which is 4x cubed dx. All right, so at this point, everything matches up. This matches this. Now the reason order doesn't matter is because this is all multiplication. It's just 4x cubed times that stuff times dx. So with multiplication, you can move around the order. So really, you're going to integrate this as if it was just x to the fourth plus 1 cubed, and the 4x cubed came later. Like this. So it's the same thing, vice versa, doesn't matter. Point is we got a du, and we've got a u that matches it. So we're all set. So they're just going to integrate. And of course, we'll do it the mathy way. So if you want to integrate this using u, you would say, oh, that's the original problem was really u cubed du, which means it's going to integrate to u to the fourth over 4 plus c, which means I've got x to the fourth plus 1 over 4 plus c, which is, I believe is the same as the problem before. I just mixed up the order stuff here. All right. Check this one out. Now this looks like a giant mess, and you might be sort of confused just looking at it as to what rule you might use here, because it kind of looks like a couple of polynomials. You're kind of hoping that there's a product rule for integration like there was for derivatives. However, there is not. There's not a product rule, so you can cross that off your list. So now we're just looking for what rule could this be. So we've got basically two things. There's two parts of this, right? We've got a 4x minus 3 that looks suspicious. And we got this massive thing that also looks suspicious, but you'll notice it has a 3 on it. that's what's making me think, this is my more likely candidate for u, because then I'd have a u cubed. The question is this 4x minus 3 part of my dx? Or my du, rather. So let's just see if that's going to work. So we'll just try setting u equals 2x squared minus 3x plus 1, which means my du, let's take the derivative of this, is going to be 4x minus 3. And of course that is all times dx. Well, look at that. That is in fact what I have here. So sure enough, this is actually a perfectly set up problem. It's going to be really easy. All we got to do is just integrate it, the power rule, and this is part of my du, so it'll just go away. So when I integrate this, I just get 2x squared minus 3x plus 1 to the new power, which is 1 bigger, which is 4, plus c. And of course that intermediate step, if your teacher is making you do it the mathy way, and that intermediate step would have been to rewrite the problem as u cubed du equals u to the 4th over 4 plus c. So we're just going to integrate it in terms of u, and then replace this u with what u equals right here. All right, not too shabby. These do get a little bit trickier. Now here's that same problem we've seen a bunch of times now, except it's missing something, and that's because our u equals x to the 4th plus 1, which means our du equals 4x cubed dx. Now the problem is I've got an x cubed dx, but I'm missing the 4. So I've got to sort of come up with a 4 right here, otherwise I can't do the problem, which means I need a 1/4 out front to make up for it. Now the logic here is that in algebra you're allowed to multiply by 1 anytime you want. That's no big deal, right? So that means if I put in a 4 and a 1/4 at the same time, I'm really multiplying by 1, because 1/4 times 4 is just 1. But I'm just going to be all clever and stuff and put the 4 right here, but then put the 1/4 out front. So the 4 gets put where I need it to make my du work out right. But then, of course, as a consequence, I got this 1/4 left over that I didn't really want, but it's okay, and now it's going to sit out front. So this just ends up integrating just like when we've seen this problem a couple of seconds ago. So we just have the same u raised to a 1 higher power with a 1/4 out front, and divided by 4. So we have this one's kind of subtle because, and it could be confusing, because we have a 1/4 out front, and that's where this came from. But then also when you integrate a power, you end up dividing by the new power, which in this case was also 4. So that generated the 4 downstairs. So that's how we end up with 1/16 times x to the 4th plus 1 to the 4th power plus c. All right, good stuff. All right, look out for negatives. I don't even know what I'm talking about. Let's see what I'm talking about. All right, so if we try and integrate this, it's pretty obviously power rule. You have an exponent of 7, which is just screaming out, hey, let's use the power rule. So my u is going to be whatever's under the exponent, which is 5 minus x squared, which my du equals negative 2x dx. All right, so that's what I'm talking about with look out for negatives. Because there's a negative sign in front of this x squared, that means my du has a negative sign in it. And of course, if you look at this problem the way it is, there is no negative sign. Now I'm going to just change the order so it's, so we got 5 minus x squared to the 7th. But then of course I'd rather have that x next to dx, since that is part of my du. But I still need a negative 2 here. I'm missing that, so I need a negative 2 here, which means I need a negative 1/2 out front to make up for it. So at this point it just works out like you would hope it would work. I'll do it the mathy way, this one. So we'll just, this is negative 1/2 integral of u to the 7th du. This will be negative 1/2. And when we integrate it, it ends up being 1/2 u to the 8th over 8 plus c. So that is negative 1/16. And then u, I got to replace with my original u, so that's 5 minus x squared to the 8th power. All right, so you can see how that u sub mathy version is not so bad most of the time. It doesn't add too much extra work, and by subbing in things and making them look like u's, just makes it look more like the integral formula for powers, which is, you know, some students like it. Me personally, and actually the way my teacher taught me back in high school was you just, just raise the power. So I would have gone straight to here from here and sort of skipped this u sub process altogether. All right, definite integrals. Mentioned this in the previous video because these can generate some extra work for you. But the basic thing is that we want to plug in, we want to integrate u sub like normal, and then just plug in the numbers. All right, so our u, pretty obvious this is a power situation, so x squared minus 3, which means my du is going to be 2x dx. All right, so I need a 2 over here. So just stick in a 2 anywhere you want to, stick in a 1/2. You kind of get used to doing this. All right, so now my u matches my du. Great. So I'm going to integrate. You know what? Let's just integrate this the fancy way. So integral 1/2. And this is where u sub is harder. So we got u cubed times du. But the problem is I got to change my limits of integration. So where I had a 1, x was starting at 1, but now u is going to start at 1 squared minus 3. I got to plug in that 1 to the u equation to find out what u would start at. So if I plug in 1 here, I got 1 minus 3 is negative 2. So now my new lower limit is negative 2. And then my new upper limit is going to be if I plug 2 into this equation right here. 2 squared is 4, minus 3 is 1. All right, so at this point I can integrate 1/2, and then u to the third is going to become u to the fourth over 4. And we don't need a plus c. That's just integrated from 2 to 1. We don't need a plus c because it's a definite integral. All right, so this is going to become 1/8 u to the fourth from negative 2 to 1. So it's going to be 1/8. And you notice I'm kind of like doing this in parentheses, so I'll put the 1/8 out front, and then I'll do my definite integral sort of in here. So u to the fourth is 1, 1 to the fourth is 1, minus negative 2 to the fourth is 16 over 8. So that is going to leave me with negative 15/8. All right, peachy keen. All right, power rule. This looks like it's pretty obviously a power rule. Let's take a crack at it. So u equals 3x squared plus 1, which means my du equals 6x dx. Uh-oh, this doesn't work. Because you'll notice my du, I've got to have a 6x next to the dx. I need a 6x right here. The 6 I could just conjure, right? I could put a 6 here, put a 1/6 out front. But the x, I cannot do that with. It's not fair to put an x right here and then a 1 over x out front. That just doesn't work. You can't do that with variables, only numbers. So we're hosed. We cannot do this with the power rule. Turns out that we can actually do it still. We just have to FOIL it because this is a low enough exponent. An exponent of 2, it's not so bad. So this is just the same as the integral of, let's FOIL it out. 3x squared plus 1, 3x squared plus 1. So we get 9x to the fourth plus 6x squared plus 1. And now we've got just a standard polynomial. No big deal, we can integrate it. So 9x to the fifth over 5 plus 6x cubed over 3 plus x plus c. So we get 9/5 x to the fifth plus, cancel the 2, 2x cubed plus x plus c. Pretty exciting. You just want to keep in mind that algebra is your friend, and a lot of times the problem will reduce using algebra, so you won't actually have to do the integral. All right, negative exponents. Just to remind you, whenever you have an x downstairs, really that's just a negative power of x. So on this one, this 1 over x cubed looks really confusing, and you're probably thinking, man, do I do power rule on 1 over x cubed, or do I power rule on this thing in parentheses? And that's where you just want to keep your thinking cap on. First of all, this thing to a third power looks like a power rule to me. That looks like the thing that matters. And then if you think about it, oh yeah, if our u is 1 over x squared minus 2, our du is just the derivative of 1 over x squared, which is actually 1 over x cubed, because if I rewrite this as a negative exponent, just rewrite my u. That 1 over x squared becomes x to the minus 2, just to rewrite it. And then when we take the derivative, we'll get negative 2 x to the negative 3 dx, which is really just negative 2 over x cubed dx. So that's where the x cubed comes from, and it turns out that this thing right here was actually did me a favor. They set me up perfectly for my du. The only thing I'm missing is instead of having a 1 upstairs, I'd really like to have a negative 2 upstairs. So I'm just going to rewrite this. 1/2 1 over x squared minus 2 cubed. And then, let's see, so I want the, I'm going to put that 1 over x cubed behind this situation. Alright, so I wish I had a negative 2. I need a negative 2. So what I'm going to do is put a negative 2 here and a negative 1/2 here, which is what we've been doing, right? Alright, so at this point I could just integrate. And the mathy version on this one might actually help me. I don't know. Let's see what happens. I'll go down here because it's run out of real estate. So if I rewrite this integral, I got the negative 1/2 out front, and then this is u cubed times du. But now I got to change my limits of integration to u's. So what we got to do here is take our upper limit and plug it into our u expression. It should be 1 over 1 minus, so 1 over 1 is 1, minus 2 is negative 1. So my new upper limit is negative 1. Then if I plug in 1/2 to my u expression, let's see, 1/2 squared is 1/4. 1 over 1/4 is 4. And then we got to do 4 minus 2 is 2. Hopefully that's correct. That's pretty wild math. Let's see if it works out. And this is the one nice thing about this u sub technique is since we did that ugly math just now to get our new limits of integration, it actually looks like it might be a simpler problem. So we need u to the 4th over 4 evaluated from 2 to negative 1. And I know that the negative 1 is above a 2, but that's just the way it works sometimes. So that's negative 1/2. Really just 1/8. Because 1/2 times 1/4 is 1/8. So u to the 4th is just 1 minus 2 to the 4th is 16. And that equals negative 15/8. Alright, pretty wild. So that's the power rule. We'll see more power rules later when we have other things raised to powers than just, powers of x. So we might have natural logs, and we might have sines and cosines and tangents and things raised to powers. So we'll be using the power rule still. Anytime you have anything raised to a good sized exponent like squared or cubed or whatever, sometimes even the first power, but no matter what is being raised to a power, it's still the power rule. But just whatever crazy function that is that your u ends up being, like u could be ln of x or sine of x or cosine of x or whatever, that's going to end up hurting you when you have to match your du. So the power rule is always the same. It's always raise the exponent by 1 and then divide by the new power. But that whole matching the du process can get really messy depending on what crazy thing is being raised to the power.